Welcome back, everybody, and thanks for stopping by. I know I'm not sure if this new all upbeat me is what you want to see, but hey, I just rhymed. Um, in this video, we're going to be doing the NAT exemption as I promised in the previous video, and the configuration is actually going to be really straightforward. As a matter of fact, let me show you what we're going to be playing with right here. So, this is going to be from ASA 1's perspective to ASA 3. So, let's go ahead and explain what's happening here. From the top down, line by line, we're going to break this down so you guys have an idea of what it is. So, the first entry, the access list encrypted traffic, means that this is the traffic that's actually going to be encrypted. So, any traffic from, that's any IP traffic, so it's going to include TCP, UDP, ICMP, anything, from the source of 10.100.0.0/16 to the destination of 192.168.15.0/24. So anything inside of those subnet blocks, and you can mix and match, you can do /24 with the /16, that's okay, is going to be permitted to be encrypted. Now, the line below that is the crypto IPv2 or crypto IPsec IPv1 transform set, tset, ESP, AES, ESP, SHA, HMAC. This line right here. Apparently I can't do a full line highlight. So this line right here is going to be the encryption mechanism and the hashing algorithm that is tied to encrypting the data between the ASAs. So this is going to be the mechanism that actually encrypts the data that goes over the VPN. The lines below, it's actually backwards. This actually should be right here. This should be, let me reverse these real quick just so that it makes a little bit more sense. All right, so this is phase 1. And this is phase 1. We should have done this before, but that's okay. You will appreciate it because you guys are awesome. So this is phase 1 communication right here. So we have to enable crypto IPv1 on the outside interface. This is the same thing as you typing a crypto map and going underneath the interface that you want to enforce encryption on a router. You type in the crypto map command at that interface, and that enables ISACamp on that port. Here's the phase 1 configuration. So pre-shared key, AES encryption, SHA is the group or hashing. Group 2 for the group 2. I forgot off the top of my head what that meant. We're not in the VPN section, so I don't have it all right down in front of me. And then we have this tunnel group. This tunnel group command is essentially the equivalent to the crypto ISACamp key command that you would use where you'd say map a peer to a key. And here we use a tunnel group and you specify the IP address. If you're doing it based off of a certificate and you have DNS enabled on the ASA, you can reach out, and if the DNS entry matches an IP address, I don't know, ASA1 at whatever.com, then that would apply here. But here we're using an IP address. And the IPv1 pre-shared key Cisco, that's going to be the pre-shared key. Now, that's phase 1. All of that is phase 1. All this is phase 1. Technically, this is phase 2, so I'll move it down to where phase 2 comes into play, which is right here. It's important to have this done. So that's technically phase 2 because it's involving the actual encryption of traffic, which is happening in phase 2. So everything above the T set right here, this is all phase 1 communication. That's pretty much the order in which you need to enter it in. There's that. And then below that, we have the transform set that we've already covered and the access list that we've already covered. The crypto map config is going to call 3 different things. It's going to call a match, and the number, the lower the number, the higher the priority. So this is like the most preferred crypto map on the ASA. And we say cryptomap1 or cmap1 match address and encrypted traffic. So it's going to match this ACL right here. Then we set the peer is going to be ASA3. We set the ISA set IKv1 transform set tset, which we're calling this for the encryption of the data. And then we're going to enable this crypto map on the outside. That's it. That is all. Good night. Have a nice day. I'm just teasing. So we enable cryptography on the outside interface, and we also apply the crypto map to the outside interface. Now, I will talk about the NAT entry in just a moment. It may look a little funny. That's okay. We're going to just literally just copy and paste this into the router, or the firewall, I should say. Go ahead and grab the ASA. We're going to grab this guy, hit the enter key a couple times, and we're going to right click and just dump it in. Boo. Yeah. So here we're going to come over here. We're going to modify this a little bit. We're going to come in here on this side and type in 10.1.10.10. Take that IP address. And same thing there. Now we have to swap the IPs because we're going to go to ASA3 and put this on, so we need to point back towards ASA1. Now, you'll notice that the encrypted traffic is still here. We actually have to swap these as well. You have to swap the source with the destination because now when traffic is coming from ASA3 going to ASA1, the 192.168.15 network is now the source, and the 10.100.0.0/16 network is the destination. Now that we have all that, we can pretty much copy and paste that into the mix on ASA3. As you can see, once you've got it up and running, it's actually pretty easy. And if anybody says this is pre-scripted, okay, whatever you say. I just wanted to speed the process up because I want to focus more on the natting portion of it than I do want on the crypto part, because VPNs are coming up and of course coming to you at your nearest whatever. So the VPN is now configured, but you might say, is it actually working? And the answer to that question would be, let me go ahead and ping 8.8.8.8. I can ping Google. Can I ping 192.168.15.15? And repeat it 100 or let's say 1,000 times? Negative. I cannot. Now, am I even doing phase 1? Am I even show crypto ISA SA? Nope, nothing. Now, why? Why is that? Now, so let's do a packet tracer. Packet tracer of input of ICMP, or from the inside VLAN 10 of ICMP. The source address is going to be 1.2.3.4. It doesn't really matter what the source address is. Actually, let me do 10.100.10.50 for kicks and giggles. And then we want to specify ICMP type 8 and code 0 for a ICMP echo. And then we're going to specify the IP address of the destination. So 192.168.15.15, and we're going to type in detailed. So we get to all that good stuff, and the very, very bottom, it says it's allowed, okay, which is actually pretty funny. So let's go ahead and scroll up just a bit and see what the dealio is. So the very top here, let's go to the very top. It says the access list is allow, which is the inbound interface of the inside interface. And we're saying it's matching all these rules. So it says, okay, there's nothing to block it, so go ahead and allow it. And we come down a little bit further. Actually, let me do this. Show run access list. Okay, cool. So let me just scroll back up. I was wondering if something else was there. Now, if we go back up to 2, which is the route lookup, which we do have a route for it, which is R1. And you'll notice that the IP address points to the egress interface, which it should, which is the outside interface. And the connection settings are decrement the TTL, no big deal. so we can see the ASA in the trace route path. And we come down here a little bit further, we see that the object of, so this is where we start getting into the NAT. So notice that the NAT entry gets triggered, right? So step 4, we're going to be natted out to the internet, even though we're trying to get to 192.168.15.15. Because, and if you look in the routing table here in just a moment, notice everything else is, it's hitting the inspection policy. So by all other accounts, we do a show route. It says if you don't have a more specific route to something, go ahead and send it out towards the internet. So if we do a show xlate, there is a ping going outbound. If we go to test 9, the ping is still there. ASA1 sees it all day long. It isn't going away. Now, the problem with this, though, if we look at the show NAT, when you look here and you see the source of VLAN 10 right here, and we hit the up arrow again, notice how this number has incremented just ever so slightly by 3 here, or it's 96 there, and then it's by 3 more here. That's because traffic is coming in from VLAN 10, 10.100.10.9, and the routing table is pointing out the outside interface, and it's going to the outside interface, and there's a NAT entry that says, okay, if traffic comes in from VLAN 10, go ahead and dynamically NAT it over to 10.1.10.10 and send it out to the internet. Okay, but that's not what we're trying to do here. We're trying to get traffic to go over to test 15, which is way over here, and we're over here, which means we have to go up towards router 1, through VIOS, down to router 2, hit ASA3, go down here. But we're hitting this, going up this way, when in reality we should be going this way and then back down from the routing perspective. So you might say, okay, well, how do I fix that? Good question. That's an awesome question. Well, on the ASA1 side, you would need to create a NAT entry, what they refer to as twice NAT, which is referred to, in this case here, is I'm going to call a NAT exemption. Now, NAT exemption is, it's read like this. So we're going to NAT from the inside to the outside. In this case here, it's going to be from inside VLAN 10. And we need to map, we're also going to specify from VLAN 10 to VLAN 10. So what this entry is saying is NAT from the inside VLAN 10 to the outside. If the source is a static entry, and so this would be the real TCP or the real subnet, and then wherever you're mapping it to. In this case here, we're mapping from VLAN 10, the 10.100.10.0/24 over to 10.100.10.0/24. So we're NATing VLAN 10 from itself to itself. So we're maintaining the source address. Then we go to the destination and we say static. I call it a remote location. A remote location in this case here is the 192.168.15.0/24 network on ASA1 side. So I'm NATing it to 192.168.15.0/24 and NATing it again. So this would be where you would be able to do the original destination can get NATed over to some other some other IP address. Now this last section is no proxy ARP, which you're not going to go out and look for an IP. You're going to just let it route outside. And the route lookup is, okay, what interface am I going to send that out of? So I'm just going to go ahead and copy and paste this into ASA1. And I'm going to go ahead and debug crypto ISA ISACamp, debug crypto IKV1. Let's say 1. I don't know how high of a crypto level I have to go, but I'm going to type in logging enable, and I'm going to go ahead, I'm going to right click and hit the enter key. So you see all these, this communication going back and forth. So now what you end up having back and forth is phase 1 is completed, and if we go to test 9, the ping is working. Now this is one-way ping, okay? This is ping from ASA1 to ASA3. And we only apply that access list, or I should say that NAT entry, to one side. So that's basically how this is coming into play. Now, if we go to ASA 1, we see this communication. So there's a bunch of other stuff that's happening and whatnot. And so I'm going to type in logging enable, no logging enable. So that cuts that off. So now what we're going to look at is show crypto ISA SA. So we have an active session between the firewalls. If we do show crypto IPsec SA, we have encrypted communication back and forth. Now, because it's been encrypted back and forth, we go to ASA 3. We do a show crypto ISA SA. We have a session there. Show crypto IPsec SA. We also have a session there. So bidirectionally, it's working. Now, the encrypted traffic is coming in, and because it's coming in as encrypted, the traffic flow works. Now, if I was to go back to here and hit the packet tracer command, see if it's going to let me do that. Yes, it will. So let me go ahead and do this again. Let me go all the way down to the bottom here. There's a lot of flows, so let me scroll up again. From the top down, the first thing you have is a route lookup, egress interface. That hasn't changed. Then we have an unnat. The unnat is the manual NAT we just entered, which says NAT. So that NAT process. So the twice NAT process kicks into play and says, okay, you know what? Since it's in the first phase, let me go ahead and unnat it. So we're not going to do anything with it. The connection settings don't get touched. Now the outbound NAT gets applied, and you have a bunch of IP options, inspection. So the inspection policy kicks into play. Everything looks good, and then you have the VPN portion. So now we go through and we say, okay, now let's go ahead and encrypt it, and we allow it to go out to the interface and be on its merry way. Now we do the same thing to here. We type in packet tracer input outside interface. ICMP, and we say the source IP address is, we'll type in 10.100.10.50, 8 and 0 to a destination of 192.168.15.15. Now we see it coming in. Oh, you know what? Show run NAT. Oh, okay. See, I made a mistake. Or no, wait. Aha. Okay. I made a mistake. So let me go ahead and do this. Let me go ahead on ASA 1. The mistake was I had something running that shouldn't have been already running. So let me go ahead and clear NAT. Or, sorry. So the mistake that I made was I was like, wow, that's interesting. Well, I don't know how that's working. I didn't let on to anything, but it seems a little fishy that it worked as quickly as it did. So if I come in and go to global config and type in clear, no. If I didn't have this command here, let me just remove this one. Let me go ahead and show run. Show run NAT. Let me go ahead and remove this line, and let's retest it to see if it works, because it should not. On this side here, we're going to do a show crypto ISA SA. We're going to do say clear crypto like v1 SA. So we should also have no IPsec SA. Cool. So now we're going to retest from test 9. Okay, this was what I was expecting it to say. So it shouldn't have worked right away when it did. And I was like, that's odd. But so we need to go and configure that same line of config, the same NAT entry on ASA3. Except for we need to reverse the roles. So on there, we're going to go ahead and pull up this guy and go back to ASA3 because the commands are still there. I'm just going to re-enable it. I'll just retype it in. So the logic is just switched. I say if traffic is coming from test 15, keep it test 15. If the destination is remote location, keep it the remote location. So I'm going to go ahead and test 9 is still chugging along, trying to ping, go back to ASA3 and hit the enter key on test 9. As soon as the VPN spins up, the communication is connected. And that's what you should expect to see. So if we do a packet tracer, now if I go to, if I hit the up arrow and I, on ASA3, if I hit the enter key and type in no NAT, and I try to do a packet tracer, input outside, and I say ICMP from a source of 10.100.10.50.80, and I say 192.168.15.15 and hit the enter key, it should be dropped by the access list. So it comes in and it's allowed, there's a route lookup, it does a NAT, it hits the access list and it's dropped. That's what you're expecting to see. Now, by throwing the NAT command in here and hitting the enter key, and then rerunning this command, the traffic should be ACL drop. We change the IP to be something different. There, that's better. So one thing I've found when it comes to VPN stuff, especially when you're doing site-to-site or you're doing remote access, is if you use any of the IPs that you're actually allocated, it bugs out. It doesn't like it when you do it. So you have to change the IP address to be something other than what you're leveraging, and then you'll be able to run through the entire. In this case here, it says ACL drop, which is kind of interesting that it says that. But with the funny thing about it is, you're not actually trying to ping from the outside interface inbound. You're actually trying to ping. You're trying to respond back. So you type in input is inside, and it's ICMP, and you're going to go to the source address of 192.168.15.10 on 8 and 0 to a destination of 10.100.10.50 and hit the enter key. This should be allowed all the way through. And it is. So that's one of those things that comes into play when you're playing around with NAT that you really need to be able to lock down. So if we go back here and we do a show crypto ISA, we have that one. Show crypto IPsec SA, we have pings going back and forth in both directions. Now, if you run into a situation where you have one side incrementing, but the other side, or in this case here, this bottom half is not. So this traffic right here, this is outbound right here. This is inbound. So you're decapsulating and decrypting. If you have incrementing encapsulated or encrypted traffic, but no incrementing counters on the decryption side, that means that one of two things has happened. Either phase 1 should have passed by that point. Normally what I'm seeing is the remote end. So in this case here, ASA3 would be pointing to the wrong IP address of ASA1, or not pointing to ASA1 at all. Or there's a there's a logic match. Something's not right on that side. So if we were to test this out again and go to ASA3 and say pull this command off, type in no NAT, and go back to ASA1, or sorry, in this case your test 9, hit the up arrow, jump out of global config, do that ping again, the ping is going to go. We go to ASA1 and we hit the up arrow. You'll see how the packets are incrementing. Include PKTS just to help you guys see it. You'll notice that the outbound is incrementing, but the decryption is not. It's staying the same, right? That's an indication that there's a problem in the data plane. Traffic is going out, but not coming back in. So this is, I've seen this a ton of times in production. I'm like, okay, send me your configs. You know, do you have this? Do you have this? Do you have that? And you can systematically start breaking down where they're missing stuff. It's like, okay, show run NAT. Do you have phase 2 running? Do you have phase 1 running? And I've seen it to where in NAT where they've got it configured, then the manual NAT exemption configured in the wrong phase. They got it configured in phase 3, not phase 1. And I'm like, oh, okay, you need to move that up to phase 1. And that should fix your problem. They move it and the problem resolves itself. So we hit the up arrow. Now we're 214 packets in. Let's go back to ASA3, hit the up arrow, and let's go ahead and pull this out and type and enter the command again. Then we go back to ASA1, hit the up arrow, and now we see packets dramatically increasing in pace because now the VPN's working. So that just goes to show you that it's easy, relatively easy. If you know what you're looking at, you can pretty easily depict, okay, why is this not working? And, you know, try to troubleshoot as to why. But that's pretty much how it breaks down, how NAT exemption comes into play, and stuff like that. I hope this was informative for you. Until next time, that is it for NAT. It might be a couple days before I get back in. I have to go and dig into modular policy framework. I have to deal with MPF for a bit. And then after that, let's see here. Let me go look at my list of things that I have to cover. After MPF is done, I have some QoS, and then I have failover scenarios, stateless and stateful, and then multi-context mode. I'll be playing around with that, see if it'll work. And then once that is done, then I have to deal with transparent firewall. Then there's a handful of other miscellaneous topics that I have to go through and play with, and that pretty much will wrap up anything that I had going on for this. So, you guys have been awesome. Thanks for stopping by, and until next time, take it easy.